So as I said, introduction to quantum mechanics is nothing but the failures of classical mechanics. There are so many phenomena that were not defined or that cannot be explained by classical mechanics. Okay, so classical theories, so we need some other theory so that we can justify our experimental result. One or two such examples were photoelectric effect and Compton effect. And what happens in photoelectric effect and Compton effect, we will just see now. So one of the failures of this classical mechanics is this photoelectric effect. That is, the theory of the photoelectric effect could not be explained by the classical theory that we have learned in classical mechanics. Now, what is photoelectric effect means? A photon of some energy, when it falls on the metal surface, an electron is being ejected. Now here what we have to understand, that this photon will have an energy equal to h nu, where h is the Planck's constant, nu the frequency, and the metal is also having a property. The property is this electron is bound to the nucleus of an atom. This electron is bound to the nucleus of an atom by some energy, right? That means this electron is in the potential of the nucleus. Nucleus is highly positive charge. So this nucleus, since it is positively charged, it will have an effect, or it will bound, or this electron which is a negatively charged particle will be bound to the nucleus with some energy, and that particular energy is called work function. Let us denote it by phi. Now we have a clear picture. Here is an electron in the metal surface which is bound to the nucleus by an energy equivalent to phi, and here is an incoming photon of energy h nu. Now when this photon falls on this electron will gain sufficient energy to overcome this potential or the force exerted by the nucleus on that electron, and this electron will get ejected out. So this is basically the photoelectric effect. Now the question is, why it is a failure? Why it is a failure? Because this is just one photon coming and hitting this electron. What happens when many photons come and fall on this metal surface? Now before going into that, this is photoelectric effect is a 1-to-1 phenomena. Now this is something that classical mechanics could not explain. In detail we will explain now. Now here you have seen there is a photon of energy h nu, and there is an electron which is bound to this nuclei by a work function phi. Now this electron is being ejected. Now what will be the kinetic energy of this electron? The kinetic energy of this electron is equal to the energy difference between the energy of the photon and the work function, right? This h nu minus phi. Now what will happen
What will happen if the energy of the photon is less than the work function? If energy of the photon is less than the work function, then no photoelectric effect will happen. No photoelectric effect. No photoelectric effect. So I am assuming here there is one photon. This is one photon hitting the one electron. Suppose two photons are hitting the same electron, one after the other, of same energy, h nu, at less than 5. Then there a chance of photoelectric effect? Still, there is no chance of photoelectric effect. So this is what is the theory of classical. That is, the classical theory was not able to explain this phenomenon. The energy is not getting added up. All right. Yes. So when this energy h nu is less than 5, there is no photoelectric effect. Okay. And what is the kinetic energy? This is the kinetic energy of the electron, by which this electron will be moving after the photoelectric effect has taken place. These are called photoelectrons. Photoelectrons. Now, one more thing. Now, what is this is the maximum kinetic energy. Okay, this is the maximum kinetic energy of the photoelectron. Yes. Now we can write this half mv square, half m v max square equal to h nu minus 5. H nu minus 5. Now let us introduce a new term called stopping potential. Stopping potential. Now once this electron is being ejected, I have to stop. If I have to stop this electron, the electron will be moving in this direction. Let me call the positive x direction. Then I have to place this is an electron which is negatively charged, so negative potential should be here. Negatively charged plate I have to keep. This should be connected to some battery, that means negative terminal. Now what should be the potential at this point, so that I have to stop this electron right away? So that particular potential, this should be V. How much voltage should be this? What is the voltage that I have to apply so that this electron which is moving with some kinetic energy, this kinetic energy is being stopped? That is called stopping potential. So kinetic energy, we already know kinetic energy equal to this much, which is equal to what? E times V. E times V, or you can write Vs to indicate it is a stopping potential. So there is another formula for stopping potential in terms of photon energy and work function, that is h nu minus 5. So this was the relation where Einstein has received Nobel Prize for in 1921, right? Not sure about this date, but still, this was the explanation to photoelectric effect. For that particular paper, he has received the Nobel Prize. Another theory that was difficult or was unable to be proven by classical theories was the Compton effect. Even this Compton effect was unable to be proved by classical mechanics. That is another failure of classical mechanics. Here you have an incident wave of wavelength lambda. This is interacting with an electron which is at rest, and the phenomena is that it is having a recoiled recoiled electron as well as scattered wave. Now why this is a failure? Why is a failure? Because when a wave interact with a matter, that means if you have these waves, okay, and there is some obstruction here, what will happen? From this obstruction there will be so many waves. This will interfere together, interference pattern you will see. But this is not what is happening in the case of this Compton effect. When a wave is interacting with the electron, this is what is happening. This is just like two body interaction. This is what you have learned in your PUC 11th and 12th. A body of mass m1 with velocity u1 is moving and hitting a mass m2 which is at rest u2 equal to 0, and what it will do? The mass m1 will move as well as m2 will move with velocity v1 and velocity v2. Now you know, with the momentum conservation and with the help of energy conservation, we can find out the values of v1 and v2, right? So our Compton effect was similar to the second process, so which indirectly tells or directly tells that the wavelength or the wave that we are discussing here is a particle. So here this is what is called Compton effect. Here you have lambda, let us call this it as lambda dash. Here you can write the h nu, the energy of the incident wave will be always larger than the scattered wave energy, but the wavelength of scattered wavelength lambda dash will be higher than the incident wave, because energy and wavelength are inversely related. So lambda dash minus lambda is equal to h by m naught c into 1 minus cos phi, where h is the Planck's constant, m naught is the rest mass of electron, c is the speed of light, phi the angle between scattered wave and the direction of incident. Now this is given by delta lambda. This is delta lambda, not lambda dash. This is change in the change in the wavelength of the incident. Now that also you have to be careful, because sometimes in the question lambda dash will be given, or sometimes the question will be to find out lambda dash instead of the Compton wave. Okay, the wavelength of the scattered wave is lambda dash. So actually what we are finding is lambda dash minus lambda, which is delta lambda. With this formula we are finding change in the wavelength. Now if phi equal to 90 degree, if phi is equal to 90 degree, this cos phi term would become 0. Then delta lambda is equal to h by m naught c, right? This is called Compton wavelength. This is called Compton wavelength. So this delta lambda from this first equation, let it be this first equation. So from this first equation we can write delta lambda is equal to del lambda c into 1 minus cos phi. All right, and the value of this lambda c, that is h by m naught c, you substitute, all are constant, h is a constant, m naught is a constant, c is a constant. The value you get is 0.0242 angstrom. You have to by heart this value. H by m naught c equal to 0.0242 angstrom into 1 minus cos phi, that is delta lambda. Now how will you find out this lambda when energy is given? For example, the Compton wavelength in such a question, the lambda, instead of lambda they will be given energy. So energy in terms of electron volt, 2 electron volt energy wavelength is falling. So how to find out? That lambda is equal to hc by e, hc by e. This, if this e is in electron volt, if this is not given in electron volt, you have to convert it into electron volt. H and c are constants. E is the given value, so lambda is equal to hc by e. This value is equal to 12400 divided by e angstrom. Forget about this electron volt now. This is 12400 by e, this much angstrom. Now how you get this formula? Energy is equal to h nu. Nu you can write it as c by lambda. So lambda is equal to hc by e. So h and c are constants. So when you substitute h and c, you will get 12400 angstrom by e. E should be in electron volt. Only then this formula will be correct. I hope this is clear. Now let us discuss once again the previous concept. That is, a wave, you have a wave, you have lambda and energy and frequency nu. Okay. So these are the how you would distinguish a wave. We have energy, wavelength and frequency. Now if energy is given, for example 2 electron volt, how will you find out this wavelength lambda? If you want the wavelength lambda, what will you do? You will first find out this electron charge, that is 1.6 into 10 to the power minus 19 coulomb. Then you know E is equal to h nu. This we can write it as hc by lambda. Then we can find lambda is equal to E divided by lambda is equal to hc divided by E. Here you have to, what you have to do, you have to write what is Planck's constant, 6.6 into 10 to the power minus 34 into the value of c, that is 3 into 10 to the power 8, again divided by energy, that is 2 into 10 to the power minus 19 into 1.6. All this work you have to do in order to find out what is the wavelength lambda. but we simplify to use in our competitive exams. This is what you can do in your theory paper. If you are writing this quantum mechanics paper, you can use this for your semester exams or year end exams, but not for competitive exams. This is not a prescribed way to go with the this usual method. For competitive exams, we have this capsules. That is, capsule is nothing but the product of this divided by this. What was that? Energy. If lambda is given in terms of Armstrong, if the lambda is given in terms of Armstrong, your energy will be 12400 divided by lambda. Once again, this lambda has to be in Armstrong. Electron volt, this much electron volt. Or if you want to find out lambda in Armstrong will be equal to 12400 energy in electron volt. Now I'll tell you, see, you have this value 2 electron volt energy. Now let us find out what is the wavelength. This is nothing but 12400 divided by 2, that is equal to, yeah, 124 means this is 6200 Armstrong. 6200 Armstrong. Your wavelength is ready within a minute. Within 10 seconds your wavelength is ready. But with this formula, if you go, even after 5 minutes you are not sure. You won't be sure whether it is correct or not. So go with this formula. If you want to find out energy, 12400 by Armstrong. If you want to find out the wavelength, this much. Or if sometimes if it is given in nanometer, what will you have to do? You just have to reduce one wait a minute. If it is lambda is given in nanometer, your energy is nothing but 1240 divided by lambda in nanometer. And if you want to find out the wavelength in nanometer, 1240 divided by energy in electron volt. Sometimes energy will be given in terms of joules. What you have to do then? You have to divide it by 1.6 into 10 to the power minus 19 to convert it into electron volt. If your energy is given in joules divided by the charge of the electron, you will be getting in electron volt. In a photoelectric effect experiment, UV light. Now once again, this here in a photoelectric experiment, photoelectric effect has to occur, it has to be either UV light, ultraviolet, or visible. Okay. Now higher energy waves are not used. Higher energy waves are not used here for photoelectric effect. Why is the question? Why higher energies are not used? Like X-ray, gamma rays are not used here. Why? Just think about this problem and think in terms of kinetic energy of the electron. Kinetic energy of this electron. What will happen to the kinetic energy when higher this frequency waves or higher energy waves are used? Then you will come to know what is the reason. Now coming back to this question, your work function phi is given as 2.1 electron volt and lambda is given. So energy of the wave is nothing but lambda in terms nanometer is given. So energy is equal to 1240 divided by 320. This much electron volt, right? So this get cancelled. 124 divided by 32. 124 divided by 32 is nothing but somewhere around 4, 8, 27. So 4 won't be around 3.8. You will get 3.8 electron volt. 3.8 or 3.9, you can write 3.9. Let it be. Okay. Now you have phi is equal to this much. So kinetic energy is equal to 3.9 minus 2.1, which is equal to 1.8 electron volt. Now this much is the energy of the kinetic energy. This much 1.8 electron volt. Now stopping potential. Stopping potential kinetic energy is equal to E times Vs. So we already know what is kinetic energy. Kinetic energy is equal to 18 electron volt, which is equal to E times Vs. So electron and electron get cancelled. Vs, so this 1.8 electron volt. So Vs is equal to 1.8 volt. Stopping potential is 1.8.
Yes, friends, before going to the next question, VK Lectures has got something for you. We are doing CSIR net classes for about 12 months, and we will have around 300 hours of class. And for PhD students, faculties, and working students, recorded classes of our video will be given to you in the link, YouTube link mainly, and in the this 12 months duration we will be solving around 3000 problems in the class, and we will almost have around 60 test papers. Weekly exams will be conducted through Google form, and we will also have question solving sections after the exam. Class timings will be from 7 to 8:30 p.m. from Monday to Friday, and this will be conducted online through Google Meet. The class will have the course will have the fee structure of 20,000, and the first 5 admissions will be giving 40% discount. That means the first 5 admissions need to pay only 12,000, and the next 5 admissions will be given 25% discount, which is 15,000 rupees. Now, what extra materials VK Lectures is providing you is around 50 plus ebooks for reference, and if students require only some particular subjects like quantum mechanics, you will be given 40 to 50 lectures of quantum mechanics, and the regarding test papers and corresponding materials will be given. And for lecture series, that means per subject you may have to pay 3,500. And yeah, so that's about our course. For details you can contact, either you can use our Gmail, or you can use our Telegram channel or WhatsApp channels for that. Thank you, and we will see the next question.
Now a question on Compton effect. Please read this question carefully. Here you have a photon of wavelength lambda is incident on a free electron at rest and is scattered in the backward direction. Now you have a wavelength lambda. Here you have a recoiled electron, and scattered electron is in the backward direction. Okay, here you have lambda, this is lambda dash. That means the phi is equal to 180 degree. Now here the question is not about lambda dash, question is not about delta lambda, that is shift in lambda. Delta lambda means shift, lambda dash minus lambda. The question is not about this also. Question is about fractional shift in lambda. What do you mean by fractional shift? How much shift has occurred with respect to the incident wavelength or incident wave? This is what is asked. Now, what is delta lambda? Delta lambda is equal to h by m naught c into 1 minus cos phi. Cos phi is cos 180. Cos 180 is nothing but minus 1. Minus 1. Cos 180 is minus 1, which means 2 times h by m naught c. That is equal to 2 times lambda c, because h by m naught c is nothing but compton wave. So what is delta lambda by lambda? Which means delta lambda by lambda is equal to 2 times lambda c by lambda. So this is the answer, 2 times lambda c by lambda. This is the fractional shift. A light described by an equation E is equal to 90 volt per meter into sine 6.28 into 10 to the power 15 second inverse into t plus sine 12.56 into 10 to the power 15 second inverse into t is incidentally on a metal surface. The work function is given as 2 electron volt, the maximum kinetic energy of the electron. Now phi is given, phi is equal to 2 electron volt. Now what we want to find out is energy of the incident. Now this wave is represented by A into sine omega 1t plus sine omega 2t. This is how a wave is represented. Omega 1 is this much, omega 2 is this much. Now let us write what we know. Kinetic energy is equal to h nu minus phi. This one we can write it as h nu into 2 pi divided by 2 pi. This h by 2 pi is nothing but h cross or h cut, and 2 pi into nu is nothing but omega, h cross omega. So the kinetic energy we can write it as h cross omega minus phi. Now if this omega is greater, kinetic energy will be more. So let us find out which omega 1 is greater or omega 2. So omega 2 is this one. So omega 2 is greater. So we can write kinetic energy is equal to h cross omega 2 minus phi. So what is h? 6.62 into 10 to the power minus 34 joule second is the unit of Planck's constant, into what is omega 2? Omega 2 is nothing but 12.56 into 10 to the power 15 second inverse divided by 2 pi, right? H cross is nothing but 2 pi, or you can write 2 into 3.14 into, this is in joules and phi is given in electron volt, so we have to divide by electric the charge of the electron, that is 1.6 into 10 to the power minus 19. So what you get? Minus, what is phi? Phi is equal to 2 electron volt. So this 2.14, sorry, 2 into 3.14 into 2.56. So this is nothing but 6.28. 6.28, it is twice that number. So one get cancelled. So 6.6 to 1.6, again that is almost 4. So 10 to the power minus 9. So this 10 to the power 15 and 10 to the power minus 34 will become 10 to the power minus 19. So what is left is 4 into 2, that is almost 8 electron volt minus 2 electron volt, which is equal to 6 electron volt. That is the maximum kinetic energy of the electron. Question will be sometimes what is the minimum kinetic energy. So instead of omega 2 you have to use omega 1, and you should also check this H cross omega 1 is greater than 5. Only then electron will get ejected. Otherwise there won't be minimum. This is the maximum kinetic energy. A photon of frequency nu falls on a photosensitive metal plate with work function phi, and thereby it knocks out an electron in a direction perpendicular to the surface. A magnetic field is applied parallel to the metal surface. Find the radius of the circular orbit made by the electron. So here uh, there is two stages. One is photoelectric effect, and another, uh, here you assume there is a metal plate and there is a photon of energy h nu, or frequency nu falls on it, and the electron is ejected perpendicularly upward, where there is a magnetic field applied parallel to the metal surface. This is the metal surface. There is a magnetic field applied parallel to this plate. So this electron ejected out will be in the magnetic field B. So the question is, if it is here, it will trace out a circular path, because there is no electric field there. It will trace out a circular path. Then what is the radius of the circular path? That is the question. So we know QVB. Q is the charge, V is the velocity, and B is the magnetic field, is equal to, this is the force due to magnetic field for a moving charge. Similarly, if it is tracing out a circular path, this force must be equal to centripetal force, which is equal to mv square divided by r. Alright. So this F magnetic should be equal to Fc. So QVB is equal to mv square by r. The question is, what is r? What is r equal to? So we can write r is equal to mv square divided by QVB. That is nothing but mv by QB. But here the question is, we don't know what is the velocity. We know about mass. Mass is mass of the electron, and Q is the charge of the electron. B is the magnetic field. A magnetic field, so you can write magnetic field B is applied. So we want to find out V, but we know one thing: half mv square kinetic energy is equal to h nu minus 5. What do you want? V. V is equal to 2 times h nu minus 5 divided by m whole to the power 1 by 2. So V equal to 2 times h nu minus 5 by m under root. Now what we can do is we just have to apply or substitute for value of V here. So we know R is equal to ME by EB into 2 divided by ME into h nu minus 5 whole to the power 1 by 2. If you want this ME inside, that you can see depending on the options, you can bring this ME inside. So it becomes 1 divided by EB 1 divided by EB into 2 times ME 2 times ME into h nu minus 5 whole to the power 1 by 2. This is your answer. This is the radius of the circular path traced by this